Approximately a century ago, humanity's understanding of the cosmos was remarkably narrow. Most astronomers believed that all of existence was confined within the Milky Way galaxy. However, in 1928, Hubble challenged this belief with accurate measurements, revealing that the universe was not stationary, it was expanding. This discovery was groundbreaking, offering an entirely new perspective on the universe. Then, in 1997, the Hubble Space Telescope made a remarkable revelation. The universe's expansion wasn't decelerating, as previously assumed it was accelerating, propelled by an unknown force now termed dark energy. This insight enabled scientists to estimate the universe's age at 13.8 billion years. However, recent observations from the James Webb Space Telescope are challenging this timeline and potentially redefining our understanding of the cosmos. Within the Milky Way lies a star cluster known as M92, whose existence raises intriguing questions. This dense assembly of ancient stars is believed to be as old as the universe itself, 13.8 billion years, yet some estimates suggest it could be even older. How can this be? The very notion seems illogical. Stars cannot exist before the universe itself, yet the data from M92 challenges our fundamental assumptions about the cosmos. Employing advanced techniques, astronomers simulated over 20,000 synthetic star populations to determine the cluster's age. The outcome was astonishing, an age so close to the universe's purported inception that it raises an unsettling question: could we have been mistaken about the universe's timeline? Enter the James Webb Space Telescope, the most sophisticated instrument humanity has ever directed toward the heavens. Webb has observed the universe like never before, uncovering galaxies that existed just 300 million years after the Big Bang. But here's the twist: these galaxies are far more massive and developed than they should be for their age. Could the universe be older than we think? The discovery of these seemingly impossible galaxies, coupled with the paradox of M92, suggests we may need to reconsider everything we assumed about the universe's age and evolution. This brings us to a bold new hypothesis: what if the universe isn't 13.8 billion years old? A recent study proposes a daring alternative: 26.7 billion years. This theory posits that our understanding of the universe's expansion and the formation of early stars and galaxies may be incomplete or even fundamentally flawed. From the enigmatic Methuselah stars that seem to defy age to the mature galaxies discovered by Webb, the evidence points toward one conclusion: we may be on the cusp of a scientific revolution. But this isn't just about numbers. If the universe's timeline is incorrect, what does that mean for our understanding of life itself? What hidden truths lie within the billions of years we've overlooked? Hidden within our cosmic neighborhood is one of the universe's most perplexing mysteries: the Methuselah star, formerly known as HD 114283. This ancient star is estimated to be 14.5 billion years old, almost a billion years older than the universe itself, according to current models. How can this be? Massive stars follow predictable life cycles, burning through their fuel at rates determined by their size and composition, yet Methuselah defies these rules, aging at a rate slower than the universe around it. The Methuselah star is more than just an anomaly, it's a beacon pointing toward deeper questions about the origins of our cosmos and the limits of human knowledge. At the heart of this debate lies a single crucial value: the Hubble constant. This number describes the rate at which the universe is expanding and is a cornerstone of cosmology. But there's an issue: the Hubble constant refuses to settle on a single value. Measurements from the early universe, based on data from the cosmic microwave background, suggest an expansion rate of 68 kilometers per second per megapar. On the other hand, measurements taken from nearby stars and Galaxies indicate a rate closer to 73. This discrepancy, known as the Hubble tension, has left scientists scratching their heads if we can't agree on the rate at which the universe is expanding. How can we accurately determine its age? What if the answer lies beyond our current understanding of physics? Could dark energy or even unknown forces be at play? One of the most groundbreaking achievements of the James Webb Space Telescope has been its ability to peer into the dark ages of the universe, the time before the first stars were born. What Webb has found there is nothing short of astonishing. Just 300 million years after the Big Bang, Webb has identified galaxies that are as massive and structured as the Milky Way galaxy. According to the current timeline, these galaxies shouldn't even exist yet. They would need billions of years to form, but Webb continues to uncover more galaxies that defy explanation. This raises a provocative question: could the Big Bang model itself be incomplete with growing evidence that the universe may be much older than 13.8 billion years? Some scientists are turning to an even more radical idea: the multiverse. What if our universe is just one of many, each with its own timeline and physical laws? In such a scenario, the apparent contradictions, such as the Methuselah star or the ancient galaxies, might actually make perfect sense. The multiverse theory suggests that our universe's apparent inconsistencies could be the result of interactions with other dimensions. If this is true, then the James Webb Space Telescope may be offering us a glimpse into these neighboring realms. If the multiverse theory holds, the implications would extend far beyond the field of astronomy, challenging the very foundations of how we perceive reality itself. As the James Webb Space Telescope compels us to re-examine the chronology of the cosmos, a once forgotten theory is regaining attention: the concept of a cyclical universe. This proposition asserts that the cosmos has not merely existed for 13.88 billion years, but has undergone innumerable cycles of expansion and contraction, big bangs succeeded by big crunches. Could the ancient stars and galaxies observed by Webb be remnants from a previous cosmic cycle? If so, what evidence might they offer about the universe that came before our own? Another enigma unveiled by the James Webb Space Telescope involves the strange presence of primordial black holes, incredibly dense entities believed to have formed within moments of the Big Bang. These black holes might be key to deciphering the development and age of the cosmos. They could also explain how galaxies that seem impossibly ancient managed to form so swiftly by serving as gravitational anchors that hastened galactic formation. Yet their existence introduces another disconcerting issue: what else are we overlooking about the early history of the universe? We already know that dark energy, the enigmatic force responsible for accelerating cosmic expansion, remains one of astronomy's greatest puzzles, but recent findings indicate that dark energy may not be a constant. Instead, it might be dynamic, altering the pace of expansion over time in ways that defy our current grasp of physics. If dark energy is indeed evolving, it could help account for the accelerated formation of galaxies and the inconsistencies in the timeline of the universe, but it also opens a Pandora's box of new mysteries at the smallest scales of reality, where quantum mechanics reigns. Time itself begins to lose coherence. Could this hold the key to the perplexities JWST has uncovered? Quantum theories propose that the primordial universe may have experienced events so bizarre that they defy classical understanding, fluctuations potent enough to birth entire galaxies, or even bend the flow of time from time dilation near black holes to the quantum fabric of the Big Bang itself. The findings revealed by the James Webb Space Telescope are forcing humanity to confront some of the most profound and unsettling questions ever posed. These breakthroughs have not only broadened our perspective of the universe, they have begun to undermine the core principles of modern cosmology, from stars older than the universe to galaxies more developed than they should be. The evidence is increasingly suggesting that the story we've been telling about the cosmos might be incomplete or even fundamentally wrong. But revising this cosmic narrative isn't merely about recalculating the age of the universe, it's about unlocking the boundless unknown and embracing the vast potential of human inquiry. What if the universe isn't truly 13.8 billion years old? What if it's 26.7 billion, or even timeless? What if our cosmos is merely a chapter in a much grander multiversal saga? One certainty remains: the James Webb Space Telescope is more than a marvel of engineering. It is a cosmic archaeologist, a window through time, and perhaps the key to existence itself. With every image it transmits, it challenges us to expand our imaginations, question accepted truths, and bravely confront the mysteries that lie ahead. So what do you believe? Are we standing at the edge of cosmic transformation as the James Webb Space Telescope continues to conduct its revolutionary research? It is appending long-held beliefs about the universe's chronology, the revelation of galaxies that seem vastly more evolved than their estimated ages, alongside the unexpected properties of ancient stars, implies that the cosmos may be significantly older than the widely accepted 13.8 billion years. In truth, some of JWST's most astonishing discoveries suggest the universe may have begun evolving far earlier than previously assumed. Utilizing cutting-edge instruments, JWST has penetrated the depths of space and identified galaxies that came into being just 300 million years after the Big Bang. These galaxies are both immense and intricately structured, exceeding what our current models predict for such an early epoch. This revelation poses a daunting question: could our current cosmic timeline be inaccurate, or at least incomplete? The detection of ancient star groups such as those in the Milky Way reinforces this suspicion. One example, the M92 cluster, has drawn considerable attention. Its stars appear to be nearly as old as the universe itself, and in some evaluations, potentially older. This contradicts traditional theories of stellar and galactic evolution. If these stars predate the formation of the earliest galaxies, it suggests that the initial conditions of the universe were drastically different from what we've long believed. Additionally, the long-standing debate surrounding the Hubble constant, the value that defines the universe's rate of expansion, remains unresolved. Desperate results from various observations only deepen the ambiguity concerning the universe's true age. The identification of increasingly ancient galaxies and star systems implies that our current calculations may be profoundly flawed, prompting comprehensive reassessment of cosmic history. As researchers delve deeper into JWST's data sets, an increasingly radical theory is taking form: the universe may have experienced multiple cycles of growth and collapse, a so-called cyclic cosmos. In this framework, the universe didn't simply originate 13.88 billion years ago with one Big Bang. Rather, it has undergone an unending procession of expansions and contractions, each cycle potentially more elaborate than the last. Thanks to these revelations, humanity now finds itself on the brink of rewriting cosmic history. Could it be that we are about to uncover a universe far older and more enigmatic than ever imagined? The James Webb Space Telescope has only just begun peeling back the veils of the universe's most closely guarded secrets, and with every new breakthrough we edge ever closer to a paradigm-shifting understanding of the cosmos.